Here's a little video of how it works. So this is a video from like recorded within the printer. So there's a camera in the printer. And this is real time. I did cut off the first 20 seconds of this video because you just have the vial rotating. What you don't see here is the light that is projecting these tomographic patterns. But what you do see is that the object, in this case, the model of a rat artery, not to scale, it's a little bit bigger, is being printed truly all at once. And this allows you to have empty channels inside, fundamental to recapitulate vasculature, ducts, all these very relevant anatomical features. And then you just wash out your construct, and then you can reclaim the material that was not cross-linked. So it's a beautiful technology inspired by computer and medical tomography. So how does it work? If some among you have been to the hospital and got a CT scan, well, how it works is that you basically get X-ray images of your body from all possible angles. And then with each of these two-dimensional X-ray images that you get, you can reconstruct a three-dimensional object inside. So we do roughly the same thing, but we don't use X-rays, we use light. And instead of capturing pictures of the three-dimensional object, we project pictures into the center. And this is what builds the three-dimensional object. So it's like a CT scanner, but the other way around. So basically, what the CT scan does is that you take your little slice of your boat, for instance, in this case, a very like our famous 3D Benchy boat, if you're familiar from it, from additive manufacturing. And you can calculate this set of X-ray projections that gives you the reconstruction. Well, we have a powerful computer doing this for you, and then the printer will take these images and then use light, visible light, to build that three-dimensional object. And this really happens within, like this polymerization process or cross-linking process really happens within 30 seconds.